Hello and welcome back. And in this video, we're going to be taking another linked list related question. And this time, we're going to be talking about detecting cycle in linked list. So the question itself says you have a singly linked list, basically, and that in that singly linked list, there is a loop or cycle that points back to one of the element in the list. And you need to actually find out if there is a cycle in the list. Is as simple as that. Just find out if there is a cycle in the list. So let's take a look at the example. So we have this list 1, 2, 3, 4, and 4 pointer is pointing to 3. 4's next pointer is pointing to 3, which is here. So we have a cycle right here. So this linked list is gonna have a cycle or a loop in it. So we're gonna return true. And if you have 1, 2, 3, 4, that means there's no cycle, so we return false in this case. Okay, so this is the question, and I want to take a moment to take a pause here, and then you guys take a first stab at it and come up with the solution, like a potential algorithm, and then come back to see what we've got for you. Okay, so pause the video here. Hope that went well. So we're gonna take a look what we've got. So let's go ahead and first understand the problem a little bit more. So we have this list. So once again, 1, 2, 3, 4, 5. I've added one more element, so to make it a little bit more easy, a little bit more like easy to explain, and more examples to go through. So 1, 2, 3, 4, 5, and 5 is pointing back to 3. Okay. Now what you're going to do is you're going to take two-pointer approach. So basically, we're going to have 2 pointers. There's going to be a fast pointer and a slow pointer. Now, fast pointer is going to jump one node, and it's going to point to next. And slow pointer is going to point to next. So while slow pointer is hopping one by one, the fast pointer is going to hop 2 nodes at a time. And ideally, if there is a loop, then they both should point at one point to one element. And as soon as that happens, we know that if they're pointing to the same reference, same memory reference, that means, or same data, basically that means that there is a cycle in the loop, and fast pointer returned back and actually started pointing back to the same element that slow pointer was pointing. So the way it goes is basically you increment, and each iteration you actually move slow pointer, and as you can see, fast pointer is jumping fast. Now when your slow pointer reaches at 3, fast pointer is going to point at 5. Now next iteration for fast pointer is going to be leaving 3, jumping to 4, and same is going to be for slow. So at this point, they both are going to be pointing at the same element. That means there was a loop in the list, and we actually found that there's a loop in the list. Okay, so that's how we solve this problem by using this two-pointer approach. So let's take a look at in the code and see how we can build it. So we're going to create a function, and function is going to be called detect loop. It's going to take a list. Once again, we're going to be working with the node, the head pointer. And what we're going to do is we're going to first check if the list is nil. If it is nil, we're simply going to return false here. Return false. Okay. Now we're going to create our 2 pointers. So slow pointer pointing to list, and fast pointer pointing to list. Okay. Then we're going to create our loop, and we're going to say slow dot next is not equal to nil, and fast dot next is not equal to nil, and we also check fast dot next is not equal to nil, because we're going to be hopping 2 times. We're going to be hopping 2 elements, skipping one and hopping to the second one. So that's why we need to check, like, if they are not nil. Okay, so we're going to simply say var slow is equal to slow dot next, and sorry, not var, not reinitializing fast is equal to fast dot next dot next. Okay, and we're gonna compare if flow dot data is equal to fast dot data. That means we have found a loop, so we're simply gonna return true here. Otherwise, we're gonna continue through the loop. Okay, and if we reach the end of the loop, we're gonna simply return false because we know that there is no loop detected, so there is no loop in the list. So let's create our list. All right, so the way we're going to create a reference is we're going to create a variable for 3. So let 3 is equal to node data 3. Okay, and instead of pointing at creating that node, we're going to simply say 3 here. Okay, and now I'm going to copy this line right here, and I'm going to say dot next, and this one is going to point to 4, and let's copy this one, and this one is going to be pointing to 5, and let's take another one next, and this is where our loop occurs. So this node is next one is going to point to 3. Okay, so now we're going to actually print, or basically call our function detect loop. Okay, and while detecting loop, we're gonna we want to find loop in the in this list right here. So that's it. So this should return us true. So there we go. We get true because yes, there is a loop in this. And if we comment this line out, comment this line out here, then we have eliminated the loop, so we should return false. Okay, all right, so that's a solution for detecting loop. There are a couple of other cases for detecting loop, such as, like, once you detected the loop, you need to find the length, you need to find the length of the loop, you need to find the start of the loop and stuff like that. So we're going to be tackling all those interview questions in next videos, so we can cover the entire topic of this iterating and detecting loop and detecting the header and the start of the loop and stuff like that. Okay, so we'll cover all those variations in next videos. All right, thank you very much for watching. I'll see you guys in the next video.